Hey TechKnowStuds, there's a couple pieces of terminology that we need to make sure that we understand. Not to mention how we apply these is going to be dependent on what we're using it for. So let's take a look at what bits, bytes, nibbles, and octets are. A bit is the simplest form. It's either a 1 or a 0. However, usually a bit doesn't sit by itself. Occasionally it does. If we want to turn something on or off, we say an on is a 1 and an off is a 0, and we call that a flag. There's flags that we'll say, hey, we want this turned on or off. But usually it's not just a bit. Usually it comes in a series of bits that represent something. A lot of times that series of bits is 8 bits. And so we call that a byte. And so this is obviously a really common term that we use out there, is a byte of data. Now we also will refer to it as an octet. So for instance, when we're talking about IP addresses, that's an octet. Oct being 8, and it's a series of 8 bits, so it's an octet. Now, there are times when a byte is too much data, or it represents too much, and so we'll actually break it down into a smaller component, and we call that a nibble. So a nibble is 4 bits. It's just half of a byte. But what's interesting is sometimes we use bits to measure things, and sometimes we use bytes to measure things. For instance, when we're talking about transmission speeds, most of the time that's considered as bits per second. The number of bits per second. So we measure speed in bits per second. But when we're talking about storage, we're measuring it in bytes. So why do we measure storage in bytes? Well, the reason is because storage is usually in blocks of data, and lots of times we're storing large amounts of data. So bits is just a little too granular for that, and we usually group things up in bytes. So that's why we measure storage in bytes. So if you're talking about some sort of removable media or disk space, then those are measured in bytes. So why do we measure speed in bits? Well, for a couple reasons. Number one is we just have a stream of bits that are coming in. Usually we have a serial interface is what we interface with other things. And so that is just in a bit. It's a stream of bits at just one at a time. So it's pretty easy to measure that a bit at a time to figure out what our speed is. But the other reason is a lot of these bits, every so often there's these parity bits or there's overhead. And so we have to factor that into our speeds. It's not just as simple as, oh, well, I have a 100 megabyte file and I'm downloading at this speed so I can easily figure out how long that's going to take. It doesn't quite work that way because of all of the overhead here. I'm on my demo laptop and I just want to show you a type of connection on this demo laptop. It's called a serial connection, and I'm going to open up PuTTY and I'm going to go to this serial connection. So this is a connection to a device, and you have some settings. The baud is the speed right here, and what I wanted to show you is the data bits. So the data bits is 8, so that's a byte. So that makes sense. I mean, that measures up with what I'm talking about, where a lot of times we group things up in bytes. And so these data bits is 8 bytes. So we'll send 8 bytes over at the same time. However, it has this stop bit of 1, and we can change it. This is the reason why it's set up this way, is because we could actually change this. So we could have more stop bits, or we could actually add some parity bits to this. And so the reason why I'm showing you this is just to show you that it's not as simple as, okay, well, let's just measure how many bytes there are, because we add extra bits to that byte when it comes to our speed and our transmitting these bytes. So how can we tell if something's using bytes or bits? Well, it is the difference between a big B and a little b. The little b is bits. So in the measurement of speed of a transmission, that's usually bits per second. So we see a little b on here, bits per second. And then with storage, that's usually measured in bytes. So that's a big B to represent that. Now, transmission speed is not always in bits. So you do have to watch out for this, because there is a difference between little b BPS and big B BPS. So, and where we see a difference with this is transmission speed of connections of to the internet is usually bits per second. But when we're dealing with something like storage, we might see bytes per second. So depending on what type of connection is, like a lot of our computer connections when it's transferring data is in bytes per second rather than bits per second. Here's a wiki article talking about data rate units. And so if we scroll down on here, we're gonna see some common technologies and the measurements of them. And at the top here, here's a lot of networking that we see here. So a lot of different types of networking technologies. And if you notice here, a lot of these have little b's to them. So that's an example of that bits per second. And so if we scroll further down, now we see things like FireWire and parallel ATA. These are SATA 2. These are things that are more built for like storage. And so now we see most of these are big B. Not all of them. Here we have USB 3.1, and this says gigabit per second versus USB 3, let's see, where's the 2.0 is megabytes per second. So we see some differences here. So I just wanted to point this out because you gotta be a little bit careful with whether it's a big B or little b when it comes to the measurement of the speed of those connections.